Hey everyone, good morning. I'm Priyanshi Agrawal and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is minimum operations to exceed threshold value 2. Okay, so let's see what is this question and how we can solve it. So in this question, you are given a zero index integer array nums and an integer k. In one operation, you will take two smallest integers x and y in nums. So from the smallest integers, what we can think of either a set, ordered set, or a queue, PI3 queue, right? Because both of them store the elements in an ordered way. Okay, and we need to remove x and y from nums and add minimum of x and y into 2 plus maximum of x and y anywhere in the array. And note that you can only apply the described operation if nums contains at least two elements. It might be the case that size of nums is equals to 1. Okay, and return the minimum number of operations needed so that all elements of the array are greater than or equals to k. Okay, so we have been given with an array nums and an integer k, and in one operation we need to remove two smallest elements of the nums, apply this operation, and then again push that number which we get after applying this operation in the nums, and then we need to do this operation again and again till there are the elements in the nums which are smaller than k. Okay, so what we can do is, let's say we will create a priority queue. Let's say 1, 2, 3, 10 and 11. I don't know what is wrong with my pen tab today. Okay, but yeah, so we will pop out two smallest element from the priority queue, right? Okay, and what we will apply this operation, minimum of x and y is minimum of 1 comma 2 is 1 multiplied by 2 plus 2, that is 4, and then we will push 4 in the queue, 3, 4, 10 and 11. Okay, again we will pop out these two elements, 3 multiplied by 2 plus 4, that is 10. Okay, now we will again push 10 in our queue, 10, 10, 11. Now we will again pop out two elements from the queue, but wait, the smallest element is already equals to the k, so we will not need to pop out these elements from the queue, or we can say nums. So how many operations we have applied? 1 and 1, that is 2, and this is our answer, right? So how we think of that we need to use queue? We can use set also, there is nothing wrong in that, but I am using queue, no worries in that. So as we have been given that there we need to take two smallest integers. So the data structure which stores the integers in an ordered way, so that we can take the two smallest integers and then again push the integer after applying this operation. That's why we think of a queue. Okay, so let's try code this so that you will get better idea. So I have defined long here. Why? Because see, the element in the nums can go up to 10 ki power 9, right? So after applying this operation, let's say what can it become? 2 into 10 ki power 9 plus 10 ki power 9. So our integer cannot store it, so that's why we have defined it as a long. So let's store the size of the nums first in n, and if n is less than 2, then we need to simply return 0. And we have been also given that the input is generated such that an answer always exists. That is, there exists some sequence of operations after which all elements of the array are greater than or equals to k, right? So either the operations can be 0 or greater than 0, but there is no default case like -1 or something, such that we cannot make the array numbers greater than or equals to k. We can make there should exist an answer. Okay, so now let's create a priority queue, long comma vector long comma greater long. Okay, now what we need to do, we need to push all the elements of the num in our priority queue. pq dot push nums of I, and we will iterate till the top element of the queue is less than k. Let's initialize our minimum operation result as 0, and while pq dot top is less than k, right? So what we will do, we will simply pop out element 1 from pq dot top, and then remove that element from q, and then pop out another element pq dot top, and then also remove that element. Okay, so now what we will do, we will push pq dot push minimum of element 1 comma element 2 multiplied by 2 plus maximum of element 1 comma element 2, right? But wait, we have initialized q with long, so they should also be long. Yeah, and now we will need to increment our operation, and finally we will return our min operations, right? So what we have done, we will iterate in the queue till the top element of the queue, it means till the minimum element of the queue is less than k. Otherwise we will simply return minimum operations. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So now let's talk about its time and space complexities. So as you can see here, we are iterating in the nums and then pushing the elements in the queue. So for iterating in the nums, its complexity will be n, and for pushing the elements in the queue, it will be log n. So its time complexity will be big O of n into log n, and its space complexity will be big O of n, as we have used the extra queue for storing all the elements. So yeah, this was all for this question. This was a pretty easy and straightforward question. I hope you get it. But if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys. See you in the next video.